11 values. Wow, I'm just looking through them and I'm seeing 103 and I'm seeing negative, let's see, the smallest value, negative 46. Quite a range of values because the range is the max, it's an equal sign, minus the min. The maximum value here is 103 minutes. And the minimum, not minutes, is a negative 46 minutes. So we end up with a range of 149 minutes. So if I'm going to do any kind of display of the data to help me visualize the distribution, like a stem plot, I could do a dot plot, but I'm just going to do a stem plot. When I draw this stem plot, it's going to be quite, I'm going to turn, let's see, my camera this way, long here. Looking at the values, everything but the last digit. So the ones digit is going to be the leaf, and the tens and 100 digit will be part of my stem. The smallest value, like we said, was a negative 46. The largest was 103. So on my stem plot, I've got to start at a negative, let's do negative 4, negative 3, negative 2, all the way. Wow, space. 9, 10. We fit it. Going through the list, the first value is a negative 30. So I'm just going to get these on here. Negative 23, 14, negative 21, negative 32, 11, negative 23, 28, 103, all the way down here. So, wow, look at the distribution on that. Negative 19, negative 5. That's actually here. It has no tens. It only has ones. So this is a negative 5. I'm just going to put it right there. Negative 5 and negative 46. You know, let's do something interesting here. I'm going to have a negative 0 and a positive 0 just to make myself happy. Negative 5, and then 1, 2, 3, and then I had to replace my 14 and my 11. All right, and then I got to negative 46, so I haven't put that one on there. I should have 11 values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So my sample size, which is a statistic. So let's start that. Statistic. Any values coming from my sample are called statistics. Nice Roman small n for sample size. I have 11 observations made in this study. I didn't do a treatment. It's not an experiment. All right. Look at the distribution of the minutes. You have a big group here that center around each other, and then you've got this tail way down here. And so I'm starting to see, I'm going to just draw something that looks like a density curve. I can definitely see that when I look at my summary statistics, the mean, the average is going to be pulled toward this 103, but the median, the halfway mark, is going to be at, let's see, the 6th value, because I have 11. So I'd have 1, 2, 3. Oh, let's fix this. It should be in order. The leaves need to be in order. Is that the only place? I believe so. All right, the leaves are in order on my stem plot. At the halfway mark would be the median, so 50% below. 1, 2, 3, 4, 5. So that's 50% are below here. So this is the bottom 50%. I'm messing up my stem plot. And then 50% above. So 1, 2, 3, 4, 5. That's an upper 50%. So upper 50%, lower 50%. And this guy right here, negative 23 minutes, would be the median. All right. Oh, that reminds me of a box plot. I've got some skewness going on. I'm really going to need a box plot. To do a box plot, I'm going to need my 5-number summary. I'm going to need a min, which I know is a negative 46. I'm going to need a max, which is 103. I'm going to need the median, and the median is negative 23. That gave me 50% to the left, 50% to the right. Now to finish out my box, I'm going to need a value that has 25% to the left, less. And the 75th percentile, this Q3, with 75% to the left, 25% to the right, I need that too. So I could technically find that. Oh, let's do that. I've messed up my values, but let's see. This bottom circle gave me the bottom 50%, and there are 5 values. So if I cut the 5 values in half, the middle one would be negative 32. So negative 32 is my first quartile. It's the 25th percentile. It has 25% below it. And then the median was negative 23. This upper 50% has 5 values. So let me get 2 values below and then 2 values above. So 11 is the 75th percentile. 75th percentile. So Q3 is the 75th percentile. 75% of the values are below it. 25% are above. Q1 is the 25th percentile. Let me write that down. Oh, I have great respect for people who do this now. Percentile. That means 25% are below, 75% are above. Now what's in between these two quartiles? It's 50%, and that spread is the interquartile range. So just to put this down, so we've got some more stats here. We, without the calculator, have found our median. The midpoint was negative 23 minutes. We found our Q1 to be negative 32. We found our Q3 to be 11. And then from these two values, the interquartile range was the difference of those two. So in other words, I need to take the difference of 11 minus a negative 32. So the interquartile range, the distance between that middle 50% is, make that positive 43. 43 minutes. Right? Minutes. So this is the actual width of the box, is the interquartile range. From Q3 to Q1, I have a length of my box of 43 units. 11 minus 32. So the length there is 43, interquartile range. The box plot goes all the way to the min with this little whiskers. Wow, this is a long whisker. So the skewness, the right skewness of this is becoming more and more evident. We see a very long spread between this 50% of values and a shorter spread between this 50% of values. So we're beginning to describe the shape, the center, and the spread of our distribution.